Let's make sure that we can work through some examples to properly use our TI calculator's normal, CDF, and inverse normal functions to deal with normal distributions. So here's the situation we'll use as our example. Suppose that we have a golfer hitting these balls. The golfer has distances that are normally distributed with a mean of 304 yards, standard deviation of 8 yards. There are two types of questions. One is where you are given a number of yards and asked to find a proportion or a percentage. That's what this first question is. We're given a number of yards and asked to find something that works with it. So I'm going to think down here for a moment. So I'm in a normal distribution where the mean is 304 yards and the standard deviation is 8 yards. And we're looking at this first question. So what proportion of the drives are over, and I'm using X since we're talking about a data value, what of these distances are over 310 yards? So I've specified my distribution, specified the problem, we're ready to calculate. So over here to our calculator, if you are finding a percentage or proportion, you want your normal CDF. Second bars, choose number 2. Here, I'm going to come back and make a quick sketch. Very rough, as you can see. We've got our mean, 304 yards is right in the middle. We want to know what's the likelihood of being over 310 yards. I'm only writing the 310 on top because there wasn't room below. So we're looking for this area that we've shaded in. To do that, I want to go from a low end of 310 up to infinity. And for infinity, we use E99. So for the E, that's second comma and then the 99. Our mean is 304 and the standard deviation is 8. Okay, so what we have is here a proportion of 0.227. If you want to write that as a percent, that would be 22.7%. And either is okay. Next up, a different type of question. What is the 43rd percentile of these distances? So this time the question's asking, okay, if I go to where I have 43% of the area below a certain cutoff, what is that cutoff? So we're finding this time a number of yards. Notice it's the reverse of what we did last time. Last time we started with yards, found a percent. This time we're starting with a percent, finding yards. And I like to write it this way. The likelihood that X is less than a particular number, and we don't know that number yet, so I'm giving it a different variable name, is 43%. That then means that that number, that Y number that we don't know, is about, well, let's go to the inverse normal. For your inverse normal, that second bar is again, it's number 3. You always put in the amount of area to the left of your cut line. So in this case, that's 43%. It is entered as a decimal. The mean and the standard deviation. And there we go. So the distance that separates the bottom 43% of driving distances is about 302.6 yards. I will typically round 1 decimal place further than the data we had. The data here is whole numbers, so I'm rounding to the nearest tenth. Okay, next up. Let's see what we've got. What percentage of drives are between 290 and 305 yards? Once again, we have yards. We're finding a percent. That's a normal CDF situation. So I'm going to off to the side again, just sketch it out real quick. Here's 304 in the middle. We're going from 290 up to 305. We're finding this area. So the proportion that are between 290 and 305 over to my normal CDF. I'm going to go from 290 to 0.305 with a mean and a standard deviation. All right, let's estimate it here. It's going to be a number that's not huge. The 290 is going to be a little low. I don't know. Let's see. We should be somewhere around, I don't know, 40 maybe? 50? Okay, that doesn't seem unreasonable. My sketch, obviously not to scale. And that 290, that's more than one standard deviation below the mean. So yeah, there's actually a good amount of area in there. So let's call it as a proportion 0.510. That's, you would round up to 510. Or as a percent, about 51.0%. So half of those balls the golfer hits would be between 290 and 305 yards away. And then lastly, what distance separates the top 5% from the rest? We're starting with a percent, finding a number of yards. That's the reverse, that's the inverse process. So on my normal curve, there's 304 in the middle. I want to cut off the top 5%. And we want to find out then what number makes that happen. So the likelihood that x is above this particular number needs to be 5%. And that then means that number should be, I don't know, let's find out. Back to our inverse normal. And here's where you have to remember. You always type in the amount of area left of the score you're trying to find. So even though we were given this 5% area, the number I type in the calculator has to be the other 95% that is below, to the left of that cut score. Always. In your mean, 304, standard deviation of 8. And let's see what we got. So it's going to be above average, more than probably one standard deviation above average. So something above 312. Let's see. Yeah, sure enough. So about 317.2 yards. So just make sure you have the right choice. Are you finding a percentage or proportion? Use your normal CDF. Do you already have a percentage or proportion? Use your inverse normal to find what you need.